Okay, hey, let me show you something. This is going to be fun. All right, watch this. I've got Photoshop open here. I'm going to open a new document, right? Um, it's 400 pixels wide, 360 pixels tall. That's fine. It's got a resolution of 72 dpi, which is pretty common for web design purposes. We like to use 72 dpi. This actually says pixels per inch. dpi, pretty much the same thing. All right. Let's go ahead and take care of that. That's fine, right? Now I'm going to set some type. Now, to be honest, I kind of hunt and peck. I do it pretty fast, but I do hunt and peck, and the mic is in the way. So excuse me a moment while I type, and there's probably be some typos. Okay. Right, first time. Oh no, this needs the capital P there. All right. Now let's take a look at this text. Right. Times New Roman. It's about 24 point. Right. In fact, if we click on it here, we can see right up in this area, it's precisely 24 points. Now, Photoshop CS6 doesn't let you flip back and forth between units as much as older versions did. So we're going to go in here and change our preferences as soon as I find where that is. There it is. Preferences, units and rulers. I'm going to tell it now that I want the type sized in pixels. Now, when I change from points to pixels, what do you think is going to happen? Well, now it's measuring type in pixel sizes. And I'm going to click here, and we see that the point size is 24 pixels. That type size did not change, right? It's exactly the same as it used to be. Now watch this. Right here, I'm running a little thing called Dablet. You can go to dablet.com and play around with this. It lets you type in some HTML and some CSS and see how things change. I have 2 sentences. This is this block. Ooh, look at that. All right. So this block right here, this is the HTML that's being rendered with the CSS. Here I don't have any CSS written, and then underneath this line right here is some HTML. So I can write some style rules in Dablet. If you've never seen it, this is pretty cool. It interprets it as you type. Right. So I can make a style rule for P. I can say P color. That's kind of a dark gray, right? There's that semicolon. And that's so basically it interprets it as you type. So let's take this first one here that I've or actually let me change this around a little bit. Sorry about that. We all make mistakes. The secret is to correct them before they go live, right? Oops. Anyway, here is the first sentence that says pixel. And then the second one has a class of point. And I'm going to make a style rule for pixel, and I'm going to set that text size to 24 pixels. See that? 24 pixels. Very good. Now, you remember in Photoshop, point size was the same as pixel size, right? So now I'm going to set the point size to be 24 points. You see that? Is that wild or what? You have any idea what's going on there? I'll let you think about that for a moment, and we'll come back to it. Okay, here's another thing I want to show you, right? We're back here in the same document. You remember that this one is, yay pixels across, yay pixels down, but the key thing here was that it was 72 dpi, right? Or 72 ppi, whichever one you want to say. I prefer dpi. It sounds a little better. Especially over the mic, fewer plosives there. Anyway, let's get rid of this right here. That's more detail than you probably needed to hear. Anyway, so I've got my canvas there. Let's change the units on these rulers. I'm usually work on web stuff, so I've got this set to pixels. Let's change that to inches, shall we? So rulers unit inches. All right, and now we're going to draw a actually let's go for a 2-inch square. Okay, so I'm gonna pull some guides over here so that I know what a 2-inch square looks like. We'll just do this very rapidly here. There we go. And then I'm going to make my little selection rectangle. I'm kind of old school Photoshop. This is the way we used to draw squares. So that's a 2-inch square, right? And I know it's square because I held down the Shift key. You might not have seen that, but I did. And let's fill that with black. We're going to save this out as an image. It's going to be a 2-inch square, right? You see that, right? 3 minus 1, that's 2. So we're going to trim the transparent pixels off of this. Why don't we save that for web? Save for web as a 2-inch square. I'm going to use a GIF instead of, or I could use a ping 8, right? That's fine. If I use JPEG, it's going to artifact the hell out of this, so we're just going to leave it as a 2-inch square there, right? 2-inch square.ping. We're going to save that. Okay, so I took a little break, and I uploaded that 2-inch square that we made in Photoshop. And you remember, we made it 2 inches square. We pulled out guides and everything. That was just a few seconds ago, for you at least. So you ought to be able to remember that. I took that image and I uploaded it to my web server, and we're looking at it in Dablet now. It's on the left, and I've put a block over here to the right, and we're going to see what happens when we size that in inches in the CSS. Now, the CSS that's here already is just there to make sure that these two things sit comfortably next to each other, right? That's all it's there for. You did know you could use inches as units in CSS, right? You can use inches, you can use millimeters, you can use centimeters, you can use all those physical units. Points are actually a physical unit too, but we'll come back to that. So I'm going to hit paste here because I've already put this on the canvas, and we're going to see what happens when I size this as 2 inches using CSS. What the hell? Right? That's like larger. That's not 2 inches. The black one is 2 inches. We know that because we sized it in Photoshop, right? That was supposed to be 2 inches, and this we say is supposed to be 2 inches, and it's not 2 inches. What's going on there, right? Now remember, in Photoshop, we said it's 72 pixels per inch, right? So that's going to be 144 pixels in 2 inches, right? So let's set this to pixels. Let's see what happens. I'm going to set this to 144 pixels. And then I'm going to set this down here to 144 pixels again, right? And they match. Now they match. Same number of pixels in there, and it's just right. I mean, except for on my monitor, there's a little slight difference due to anti-aliasing of edges, I think. But you know, other than that, it pretty much matches 144 pixels. So obviously, there's something else going on here. And when things get that confusing, there's only really one thing to do, and that is to go to the spec and see if we can figure out what's going on there. So let's take a look at the CSS3 spec, shall we? Okay, I apologize for the jump cut, but you know, these are the things that we have to do unless you want to watch me Google for this page and all that kind of good stuff, which I'm sure you don't want to. We're on the page here that describes the values and units for CSS, and you see this has been updated just a few days ago. This is today is August the 11th or 12th or something like that. They all kind of run together. Anyway, let's see if we can find a bit about pixels, shall we? Right? Now look here. It says absolute length units are fixed in relation to each other and anchored to some physical measurement. They are mainly useful when the output environment is known. The absolute units consist of the physical units, inches, centimeters, millimeters, point, PC, that would be pica, and the pixel unit, right? And down here we see it says pixels. 1 pixel is equal to 1/96th of 1 inch. So that says, as far as the W3C is concerned, and therefore as far as all browsers are concerned, 1 pixel is not 1/72nd of an inch, it is 1/96th of an inch, right? Now, let's think about what that means, right? Points are a physical unit, right? And 1 point is equal to 1/72nd of 1 inch. There's a good reason for that. It's because when Apple first set up their screen sizes for the Macintosh in the 80s, they decided to use 1/72nd of an inch for the size of their pixel on their screens, because they were doing this thing called WYSIWYG desktop publishing. That might ring a bell for some of you older people. And the point was a well-known publisher's unit of measurement, and it was 1/72nd of an inch. So they said, hey, let's just make things easy. We'll make a pixel on the screen the same size as a point, and then when the people draw something on their screen, it will look at what they see on the page. So that's what we got, right? And people still continue to use that kind of rule of thumb that 1 pixel is equal to 1 point is equal to 1/72nd of an inch when they're working in Photoshop. So it makes it easy to say, do things to convert between pixels and points, and think in physical units that way. The problem is that pixels are not 1/72nd of an inch anymore. They're 1/96th of an inch, or they're 1/215th of an inch. The pixel sizes have changed an awful lot. What does that tell us about our font sizes? Let's go back to our tablet. Now, using that, we can convert. Now we know we want a point size of 24 points, so we can say here font size 24 point. Pixel size, right? 24 pixels. Obviously, that's not right. So what we need to do is we need to multiply the number, the point size times 1.33. That'll tell us how many pixels we need to have. All right, so I'm going to pop open my little calculator here, and we're going to say 24 times 1.3333333333. So at some point it decides, obviously this is not true, but at some point it decides that that's as near as 32 as makes no difference. So we will go ahead and copy that and paste our 32 there. Now that text matches up, right? So what's happened here is we're designing at 72 pixels per inch, which makes the math easier. And then if we start using physical units on the CSS page, right, like points, inches, centimeters, or all the other dimensions that we specify using that, grow by 1.33, a factor of 1.33. Or if you want to think about it the other way, all the images, all the bitmap images that you've produced seem to shrink by 3/4. So you can't really mix the physical units with stuff that comes out of Photoshop. We call bitmap graphics that are specified using pixels, unless you're using a design layout that says 96 pixels an inch, and then you can do that math appropriately. There's one other wrinkle though. When I made that 2-inch square and I put it up on my screen, it wasn't 2 inches. It was smaller. And when I know that because I took a measuring tape and I measured it, and it was smaller than 2 inches. And the reason that it was smaller than 2 inches is because my monitor is not 96 pixels per inch. My monitor is considerably denser than that. So it made that thing that was nominally 96 pixels per inch look smaller on my screen, right? So it's not really an inch. There's kind of a fiction going on there. You might be asking yourself, why is it that I hadn't noticed, moving from comp to the web page, why is it that none of these issues have come up before, And the question is, have you been using points? Probably you haven't. I suspect the font sizing units that you've been using have been pixels or ems or percentages, right? That's all you've been using. There's a percentage, right? That's what you've been using. You haven't been using points, and you haven't been using centimeters or millimeters, 20 millimeters, whatever size that is, right? You haven't been doing that. You might have at one point experimented with points and then realized that they get radically different results in different environments. And now you know why, right? But as long as you're not mixing these values, pixels, ems, and percentages, with real-world dimensions, you're fine. It doesn't matter what resolution your comp is in. But once you start trying to get that precision in there, that's when you start having a problem. So the moral of the story, before I get into precisely what a pixel is that you really shouldn't be using the physical units anyway, and that's what the W3C has always said. That's really only for output that is dimensionally accurate, like papers, like billboards, right? If you're designing a billboard display in CSS, then go ahead and say inches or feet or whatever you want to do. I have never designed a billboard with CSS, so it really hasn't been an issue except for the touch devices, right? And once the touch devices came out, we started building websites, responsive websites for touch devices. People would say, "Oh, well, your font size needs to be at least 12 point to be readable." 12 point is different on everybody's device, even though a point is supposed to be 1/72 of an inch. It's always interpreted at this one pixel is 1/96 of an inch. So a point is small on highly dense screens, and it's large on very large screens. Anyway, that's the moral. You can shut me off right now. But if you want to hear what pixels are really about, I can help you with that. It just gets a little nerdy. All right? Okay, so here we have the W3C's definition of a reference pixel, and it's a bit on the long side. I don't want to read it all to you. Basically, what it boils down to is a pixel on a device is supposed to have a visual angle of 0.0213 degrees. And that means if you're looking at a device that you're supposed to hold close to your face, a pixel is going to be fairly small. And if you're looking at something a great distance away, a pixel ought to be fairly large, right? A desktop monitor, which is the classic example, is going to be about 28 inches away from you, and it's supposed to have a pixel size of about 1/96 of an inch, and that's why they chose that figure, right? Now, this diagram that they put here is total gibberish to me. Originally, it took a lot of research into figuring out what visual angle was. As I said, I'm not a computer scientist, nor am I a mathematician. So I really needed to find somebody to explain this to me, and I'm going to try and explain it a little better to you now. So let's move away from this fairly useless diagram and look in Photoshop where I can draw you some more pretty pictures. Okay, so what I have here is a diagram that I'll use to demonstrate visual angle as it relates to physical objects, which don't change size. Here I have the Eiffel Tower on the right and an eyeball on the left. I'm responsible for drawing the eyeball. I'm not a computer scientist. I'm not a mathematician. I'm also not an artist, but it's close enough. So when you look at something, right, you can imagine imaginary lines coming from, say, the top and bottom of the thing, and they converge on the lens of your eye, roughly like this. And the image is upside down on the back of your eye. And then the brain goes through some calisthenics to turn it back right side up in your head, which is a perfect metaphor for programming. And if any of you are programmers, you understand what I'm talking about. Anyway, so what we see here is we have these two lines that converge right here in the middle of the eye in the lens, right? And this angle, which is, if you remember your basic geometry, the same size as this angle right here, is called the visual angle, right? And it's the angle between those imaginary lines right there. Now, the thing about real-world objects, as they get closer to you, they take up more and more of your field of vision, which you can kind of roughly visualize like this. I'll turn off this set of lines right here, and we can see the Eiffel Tower closer, right? And we see that the visual angle here has gotten much, much larger. And the Eiffel Tower takes up considerably more of the space on the back of the eyeball. And at this point, realistically, you probably wouldn't be able to see it all at once. So the secret is, as things get closer to you, their apparent visual angle, which is this angle right here, that apparent visual angle gets larger and larger and larger. The trick with pixels is they want them sized so that they appear to take up about the same visual angle from a comfortable distance, so that basically the same field of view is in place. So that's what this image here is trying to illustrate. It's not the angle that changes, right? It's the size of the object you're looking at. So if you say this is a jumbotron, the pixel needs to be that big. If it's a desktop monitor, it needs to be this big. If it's a handheld device, it needs to be this big, right? So the pixel size changes in relation to where you place it in your hand. Like I said, that was all well and good until we started touching our screens. It's great that you can design something right up in front of your face that's going to look just great half a stadium away on a big enough display. But once you start having to touch things, it gets a lot more complicated because you need things to be big enough to read, right? But you also need them to be big enough to touch. And if you make things big enough to touch on a display that's an iPhone display that you hold close to your face, once you put it on a jumbotron, that touch target is going to be larger than somebody's head. So that's one of the complexities of mobile design, and it's something we're still working our way through right now. The technology is still very new, the medium is still very new, the artistic expression is just, the idea of having an infinitely sized canvas or infinitely variable canvas that we use in multiple different varieties or multiple different contexts, and then somebody has to design for that and plan it through. That's really, really unusual. There's nothing like that. There's never been anything like that. So it's going to take some time, and it's going to take some time for the specifications like the one we're looking at here to catch up, and the technology as well. But for the time being, we cannot be precise about our touch targets. We cannot be precise about our font sizes. We can't make sure that everything looks 12 point on everybody's screen if we assume that a point is 1/72 of an inch, of a real world inch, and not just some measure of the number of pixels that are there. So I'm done nerding at you. If you have any questions about pixels, if you have any new information to share, and especially if you have used CSS to design large-scale displays such as billboards, I would really like to hear from you. You can reach me at john@insidenewcity.com, or you can also reach me at john@anvilania.com. Thank you very much. Bye.